Welcome to CS3308 Information Retrieval. This is the Unit 1 Lecture Part 2. And we're going to continue on with the conversation that we had started in Lecture 1 by digging a little bit deeper into these ideas of what is an information retrieval system. So we talked a little bit before about different information retrieval models in the previous lecture. In this lecture, we want to kind of move on and start looking at how I take those models and implement them into an information retrieval system. Now, in our particular case, what we're looking at is an information retrieval system that is computerized, is based upon some kind of a computer program. And if you kind of think about the typical model, and Google's just a great example of it, we can see up here we have kind of our whole search screen. Everyone should be pretty familiar with that. And I kind of put my query terms in here, and I press the button here. Now, essentially what happens is that those query terms get sent into Google's information retrieval system. Right? And essentially what Google's going to do is it's going to take those terms and it's going to go and query against an index. And we're going to talk a little bit about what that index is and how it gets created in just a minute. The index is going to return to us all of the documents that are relevant to the search terms that I have. And quite frankly, it's not going to return them all because in the case of Google, there may be millions or even billions of documents that are relevant. But it's going to rank those documents based upon relevance or what it's perceived as the relevance based upon the terms that I've used. And then I'm going to kind of return that to the browser and we can kind of see the kind of response that we typically get out of a web search. Now, really important concepts that are going on here is this index and applying this query term or the query that I'm executing, the terms and or the query nomenclature, for example, when I'm doing Boolean where I might be using the and, or, and not terms, right? Because that might be part of my query. Or in this particular case, I'm querying on the terms information, retrieval, right? So essentially I'm taking these terms, I'm going to an index, I'm looking up in that index for these terms, and then I'm returning all the documents that might be relevant to that. Okay, and let's just kind of look at this index concept, and this is what we really want to focus on in this lecture is what the heck is this index and how does it work? How do we build it? And that's really important because that's one of the first things we're going to start doing in this class is actually building out an index. Now, I'm going to kind of go into the talk about a little bit about that. As far as the assignments in this course, we're going to kind of cheat a little bit. So instead of building the index in the way that we would typically do it when we were trying to build an information retrieval system, we're going to kind of cheat a little bit. We're going to use a database for it. And the reason why is because there's a lot of sophistication in trying to develop all of the code necessary to build the index. And what we really want to focus on in this class is understanding what it is and how it works. We're going to talk a little bit about the technology we would typically be using to build that index. But just suffice it to say that in an effort to kind of skinny down the size of the scope of the assignments such that they're doable within the format of an 8-week course, we're actually going to cheat a little bit. We're going to use a database so that we don't have to do all the sorting and merging and things that would normally have to happen in a information retrieval index. Now, so when we start thinking about this model, I take my terms, I send them down to the search, I get some response that comes back. There's a couple of different ways that we can do that. And the first one is I can go through, just kind of a linear search of all the documents. Now, there's a great example, those of you that are familiar with Unix or Linux, of this kind of an approach, and that is the grep tool, right? The grep tool is going to go out and it's going to go file by file. It's going to search for the particular words or terms that it's been given, and it's going to kind of return all of those that meet that criteria. Now, this is perfectly fine, but it has a bit of a problem in that it's asymptotically complex. And for those of you that have had the data structures and or analysis of algorithms courses, you're going to be familiar with this concept of asymptotically complex. And what that basically gets down to is that it's that we are worried about what happens as n, or in this case, think of n as the number of documents. So as the number of documents increases in size, it takes much longer to search, right? So when n grows large, it's going to be something slow to do. Imagine having to execute grep across 1 billion documents. And in the case of Google, that's very much what we're looking at. We're literally looking at potentially billions of documents. Maybe some of those documents are books, and some of them are PDF files, and some of them are web pages, but there are millions and millions, if not into the billions of them. So we know that grep isn't going to be a good solution because it's going to be very, very slow, because n is going to be large. The alternative to this is that we can use an approach called indexing. Now, indexing is asymptotically less complex. Okay, it remains fast. In other words, it's going to be relatively quick to execute even when the size of n grows large. And the benefit of indexing is it's always open to improvements in algorithm efficiency. Now, one of the ways that we might think about indexing, and for those of you that have had data structures and you kind of understand the idea of a binary search or a binary tree, B tree concept, but the basic idea is I take some list of terms, and let's say they're all in sorted order with all the A's at the front and all the Z's at the end, right? And the way that I can search that is I can take some term, and let's say our term is information, right? So I know that I is kind of halfway, it's not quite halfway through the alphabet. So what I do is I say I'm going to take this half of the list, and then I divide it in half. And then I decide if information is higher or lower than this point here. And it's probably going to be higher. Then I cut that again in half, and then I cut it in half until I get to the point where I find the word. So it means that I'm able to find something rather quickly using this binary search concept. Indexing is going to be better because it's always going to be asymptotically less complex. Now, as you probably are seeing right here, what that means is in order for me to do this kind of a search with an index, I have to kind of get it into sorted order, and we're going to deal with that problem in just a little bit because, again, we are dealing with billions potentially of documents, and I've got to do something to sort stuff. And what I'm really looking for and what I'm sorting here is all the words in those documents, which we know can be very, very large. So again, there's some challenges in all of this. However, indexing is always going to be our way. So in information retrieval, we have this concept called the inverted index. And so the basic idea here is that, what we're typically going to be searching on, when we go build a query, so in the example that I gave, we said it was information and retrieval. These are our two terms, right? Basically, these are words. And I'm going to go to an index, and I'm going to search for these words. And essentially what's going to happen is I'm going to try to identify all the documents that perhaps have the word information. And then I'm going to say, I'm going to look for all the documents that have the word retrieval. And then I'm going to say, what is the intersection of the two? In other words, which documents have both information and retrieval in common? Now, the way that I do that is with this concept of an inverted index. So essentially in an inverted index, the way that we build it is that I take every single one of the documents or web pages or whatever it happens to be, and I extract from it all the words. So I kind of tokenize it. We use this term token. So I look for words and terms and things of that nature, right? And so for every one of those terms, I'm going to go put that term in a dictionary. So for example, if I were looking at Shakespeare, if I was indexing Shakespeare documents, I might have terms such as Brutus and Caesar and Calpurnia. Now, essentially, all of these things go into what we call a dictionary, and that dictionary winds up getting sorted. So the dictionary then has something we call a postings list. So every time I encounter a document that has the term Brutus in it, I go and I assign to that document some sort of an identifier, usually going to be a number. So for example, maybe that's document 1 or document 174 or document 10,432. It doesn't matter. But basically, all of these represent documents. They're numbers that point to a document, and we call that the postings. This essentially is the inverted index, where I have a dictionary of terms, and each dictionary of terms points to a posting list. Now we're going to get into the fact that in addition, we're also going to have a piece of information for each one of these postings that tells me the frequency of the word within the posting. So for example, if Brutus, the word, appears 5 times in document number 1, I'm going to want to keep track of that as well. But that's essentially what the structure of the inverted index is. Now, the postings list is so again, we've talked about the dictionary, and we've kind of talked about the postings list, and each of the postings list is going to have every single one of the documents. So these tend to be variable length. Generally, we can put them in memory, and we structure them as linked lists. And one of the things about information retrieval is that you need to have speed. So one of the things we tend to do is we want to try to figure out, how do we squeeze stuff down small enough? How do I get the vast majority of the index elements in physical memory on a computer? And this is very important because I can search memory quickly. I can't search disk spaces quickly. And even though our dictionary is going to be ordered in alphabetical order so that I'm able to do binary searches, and even though I'm going to compress the posting list down to just a document ID, or generally going to be represented in, just a couple of 3 or 4 bytes for every document, it's still going to become an issue in terms of space, given the fact that the size of n, or the number of documents that I'm going to deal with, will become relatively large. So the process of actually building this index, and the index again we're talking about here is the inverted index, which has the dictionary and the postings list, is that we're going to take all the documents that we have to be indexed, and we're going to run them through a tokenizer. And a tokenizer does nothing more than extracts each one of the words. Basically the way that it does that is it looks for anything that's surrounded by white space. So if I had the sentence, the brown fox, I would identify the word "the" as a token because it has a space between it and the next word, which is brown. Right? So whenever I see this kind of white space, I can identify that as being a token or a word. In this case, the brown fox. Each of those would be a token. Each one would be extracted separately, and I would be able to recognize that through things such as the white space, or the spaces that I put between words. So first step, tokenization. Once I have these tokens, such as friends, Romans, countrymen, right, I might go through some kind of processing on them. We're going to talk a little bit about what some of those processing that we might do on that. And it boils down to some things we're going to call and refer to as lemmatization or stemming. But just think of it as, I got to make sure that I can be as consistent as I possibly can be with these words. So for example, we can kind of see how I've gotten rid of the S, right? Because friend and friends both imply the same kind of concept. It's just one is plural, one is singular. So this is the kinds of things that we're doing in the linguistic modules, is trying to get these things down to very consistent, right? Notice I remove the capitalization, right? Such that I'm down to the root or the base of the word in every case. And then once I have this, I'm going to actually go through the indexing process. And the way it typically works is I might take the word friend, I'm going to go into the dictionary and say, do I have the word friend in my dictionary right now? If I do, great. I'm just going to add another document into the postings list. If I don't have it in there, then I'm going to want to add it. So once I've dealt with this term in the postings list, then I have to go back in and say, for every new word that's coming out of that document that I'm processing, I have to make sure that I go add the document into the postings list for that particular term. So hopefully that gives you some sense of how that works. And again, so kind of looking at it again in a different perspective, the process is going to involve tokenization, which means extracting all the words from a document, normalization, and I think that these are a number of things that kind of sit in this whole linguistic module section, but normalization, which is kind of getting things where I'm getting rid of the punctuation, I'm getting rid of the capitalization, I'm getting rid of, in this particular case, we can see it, the periods. Stemming, the idea is to get down to a root of a particular word. And then we also have a concept we call stop words. So, for example, in the English language, we have a lot of these really short, often used words that we use to connect stuff together. And quite frankly, they don't have a lot of information value. The word "the" is going to appear in just about every single document out there if it's in English, and it has absolutely no relevance to anything. So what we tend to do is we just get rid of them. We call them stop words, and stop in the sense that we don't put them into the inverted index because they quite frankly don't have any information value. Now, there are some fields of thought that say that we should keep stop words, and some of the newer technologies are trying to get more semantically correct, where we're looking not only at individual words as terms, but maybe phrases or sentences, and in those cases that these words become more relevant. But as a general rule, and for the purposes of what we're going to do in this class, we'll have stop words as those things that are so common that they don't have much information value, and as a result, we want to get rid of them.